This next set of videos is on ions and ionic compounds. We'll begin by talking about monoatomic ions, and we'll start by giving some general definitions. Ion is where the number of protons and the number of electrons in an atom are not equal, which results in an electrical charge on the atom. Cation is formed when you remove electrons, so you get a positively charged ion because the number of protons is greater than the number of electrons. Conversely, an anion is formed when you add electrons to an atom, so you get a negatively charged ion, or the number of protons is less than the number of electrons. We talk about the ionic charge, which is the number of protons minus the number of electrons, and this number can obviously be positive or negative. And lastly, we talk about valence electrons, the electrons on the highest energy level, the octet rule. An atom is at a lower energy state when its valence shell is full, otherwise known as an atom is at a lower energy state when it has a noble gas configuration. How do you get to 8 valence electrons? You subtract x or add y, where x is the number of valence electrons, y equals 8 minus the number of valence electrons, and then you see which is smaller, x or y. If x is smaller, you will lose electrons and create a cation. If y is smaller, you will gain electrons and create an anion. For elements in the S or P block, otherwise known as representative elements, you can figure out the number of valence electrons by looking at the periodic table. Now, the S block are the first 2 tall columns, the P block is the last 6 tall columns, and all of the elements in column 1 have 1 valence electron. All of the electrons in column 2 have 2 valence electrons. Tall column 3, or column 13, have 3 valence electrons, so on and so forth. So, how many valence electrons does radium have? The first thing you do is find radium. You see it's in the second tall column. That means it has 2 valence electrons. Now, what is the charge on a radium ion? It's in the second tall column, so it has 2 valence electrons. Lose 2 or gain 6. 2 is less than 6, so it will lose electrons. Loss of electrons results in an anion, or a positively charged ion, so it becomes radium 2+. What is the charge on an arsenic ion? The first thing you do is find the arsenic. It's in the 5th tall column, so it has 5 valence electrons. Lose 5 or gain 3. 5 is greater than 3, so you gain electrons. The gain of electrons results in a cation, or a negatively charged ion, so you would say you have arsenic 3-. Now, what about the elements in the D block, otherwise known as the transition metals? Technically, all the elements in the D block have 2 valence electrons, but it's a bit more complicated than that. We're not going to go into the reasons, just accept it. So you will need to be told how many valence electrons for an ion in the transition metals. This is where the Roman numerals come in. The Roman numeral after an element's name or symbol equals the positive charge on an ion formed from that metal. So, for example, iron 2, the ion of the iron here will be 2+. Iron 3, the ion of this atom would be 3+. Cu1 means a charge of 1+. Cu2, or copper 2, means a charge of 2+, and so on and so forth. The Roman numeral equals the positive charge. There are some exceptions, and you need to memorize these. Lead and tin, which are representative elements, act like transition metals, and they need Roman numerals. Silver always forms a 1+ charge. Zinc and cadmium are always 2+. You don't need to use the Roman numerals, but if you do, you won't be penalized. Now remember, metals always form anions. Nonmetals, when they ionize, will always form cations. And the cations will always be as expected. There's never a need for Roman numerals there. So, if I ionize gallium, its charge would be plus. Why? It's in the 3rd tall column. It has 3 valence electrons. Lose 3 or gain 5. 3 is less than 5, so you're going to lose the 3 electrons. That gives you a positive charge. The charge would be 3+. If I wanted to give the formal name to the Cr3+ ion, it would be written out as chromium 3 ion, or just chromium 3. Chromium is in the D block, so it needs a Roman numeral. 3 equals the 3 I's in Roman numerals, so you now have the chromium 3 ion. The zinc ion would be written out as zinc ion. Zinc is in the D block, but it is one of the exceptions to the rule of needing a Roman numeral. So to review, ions exist when the number of protons and the number of electrons are not equal. More protons than electrons is a positive charge, or a cation. Fewer protons than electrons results in a negative charge, or an anion. Metals can only lose electrons. Nonmetals can gain electrons. Elements in the S and P block, otherwise known as representative elements, you can figure out the charge from the periodic table. For the transition metals, or the D block, the charge will be positive, and the Roman numeral will tell you the ionic charge, but there are exceptions. Tin and lead need Roman numerals, and actually the Roman numerals will either be 2 or 4. Silver, when ionized, is always 1+. Cadmium and zinc, when ionized, are always 2+. That completes the talk on monoatomic ions. In the next video, which should be shorter, will be on polyatomic ions.